Hello everyone, my name is Yishi Zhang. I'm presenting Vroom, a search engine for sounds by Vocal Imitation Queries. This paper is co-authored by Junbo Hu and Yiting Zhang, Professor Brian Pardo, and my PhD advisor, Professor Zhiyao Duan. In traditional text-based sound search engines, like FreeSound and Google, a user typically types in keywords, and the search engine returns the user with a bunch of sound candidates. However, the keywords are often not specific enough, and the returned sounds often show a greater variety. For example, when we search a clock alarm in FreeSound, hundreds of sounds are returned, and they sound quite differently. So one would have to listen through the entire list to find the exact match. This is why we designed an alternative search approach for sounds, using vocal imitation as the query. Vocal imitation is a common human behavior that uses vocalization to mimic sound. It is widely used in our daily life. Those of you from the US might know a famous radio program on NPR called Car Talk, where audiences call in to describe their car problems using vocal imitation for the hosts to make diagnoses. In this work, we designed a Vroom system just to do that. It takes a vocal imitation query and then finds similar sounds in a database. In this paper, we would like to answer two research questions. First, is vocal imitation-based search an acceptable approach to sound search for ordinary users? Second, how does vocal imitation-based search compare with the traditional text-based search for different kinds of sounds? To answer these questions, we designed a vocal imitation-based search engine called Vroom. We then conducted a user study on Amazon Mechanical Turk to compare Vroom with a text-based search engine baseline. The front-end GUI of Vroom allows the user to record a vocal imitation query of a sound from a certain category. The user can listen to the recording, inspect the waveform, and re-record if necessary. By clicking on the Go Search button, the vocal imitation is uploaded to the backend server and is compared with each sound within the specific category. Sound candidates are returned to the user with descending similarity scores. The backend algorithm is a deep neural network called CHIIR. It is a new and a lightweight semi-style neural network following our previous work. It receives a vocal imitation and a sound candidate as the input, extracts features, and calculates a similarity score between them. For comparison, we designed a text-based search engine called TextSearch as the baseline. It allows a user to enter keywords to find sounds with a similar tags. The backend is realized using the Apache Solr platform, where each sound is stored in a tree structure with sound file names, tags, and IDs. This front-end workflow and the backend Solr-based search algorithm are also used in FreeSound. This guarantees the search effectiveness and efficiency of the baseline. We create a new dataset called FreeSoundIdeas as our sound library for subjective evaluation. The ontology is created by referencing sound descriptions and the ontology of sound ideas. There are 8 top-layer sound categories, such as animal, human, music, synthesizers, etc. The number of sound concepts in each category is shown in the brackets. For the actual sounds, we do not use sounds from SoundIdeas due to copyright restrictions. Instead, we use their keywords to search similar sounds from FreeSound. To make quantitative comparisons between Vroom and TextSearch, we designed an experimental framework that wraps around each search engine. The framework guides each subject to make 10 searches. Each search takes 3 steps. In step 1, the subject listens to a reference sound that is randomly chosen from a category. The category's name is visible while the keywords of the sound are hidden. This sound will be the target sound to search. In step 2, the target is hidden away from the subject, and the subject uses the search engine, Vroom or TextSearch, to search for the target in a specific sound category. In step 3, the target appears again for the user to compare it with the retrieved sound and rate their satisfaction about the search. We recruited a total of 200 subjects from Amazon Mechanical Turk. 100 for each search engine without overlaps. The gender distribution is quite even, and a large portion were born in the 1980s and the 1990s. Most subjects were white Caucasian, followed by Black, African American, and Asian. We paid each subject $1.5 for Vroom and $1 for TextSearch, considering their average time spending. Subjects were informed about this compensation policy before starting the experiments. In this figure, we compare two types of user ratings between Vroom and TextSearch. First, user satisfaction rating indicates how satisfied a user is with each search by comparing the finally retrieved sound to the reference sound. Second, the ease of use rating evaluates a user's overall experience of each search engine upon the completion of all 10 searches. Vroom shows a statistically significantly higher ease of use rating than TextSearch at a significance level of 0.05. The average satisfaction rating of all categories shows slightly better performance of Vroom than TextSearch, but it varies from one category to another. For music, natural sounds, synthesizers, and tools and miscellaneous, Vroom receives a statistically significantly higher satisfaction rating than TextSearch. This is because many subjects could not find appropriate keywords to search in TextSearch. For animal, human, office, and home, TextSearch outperforms Vroom significantly. We believe that subjects were more familiar with these sounds from their everyday experience and knew how to describe them using keywords. While some sounds could be difficult to imitate, such as shuffling cards and toilet flushing, the ease of use rating comparison suggests a positive answer to the first research question. User satisfaction rating comparison as a subjective evaluation answers the second research question in terms of search effectiveness. More detailed analysis answers the second research question in terms of search efficiency, which can be found in our paper's experimental results section. Here is a live demo of Vroom. The website is vocalimitation.com. Let's imitate an engine sound. Click Record. Select the transportation category, then go search. We have top 5 returned sounds. They are speedboat, diesel truck, etc. They're exactly the engine sound effects we are looking for. For future work, there are lots of aspects to explore to improve the search experience, such as combining vocal imitation-based search and a text-based search. And we can also do online adaptation to different users' preferences. We hope this novel search method for sounds will be soon part of our internet experiences. That's it. Thank you for your attention.